I've been requested recently to make a video about how the air induction systems on automobiles work, or manifolds, or air input, whatever you want to call it. We'll start off with explaining it on a Honda, because this is a very common tuner type car and lots of people put cold air induction pipes and swear by them. What can I induce you to do? How come I always got kitties popping into my videos? Well, anyways, back to business. So we have a typical stock induction system on this 1995 Honda. Multi-port fuel injection with the fuel feed rail. These long tubes are called runners. This air storage box is called a plenum. And people like to put shiny, smooth pipes in a different air cleaner box on the intake snorkel. Well, as you notice, the intake snorkel has a few ribs on it because your motor flexes back and forth. And it's not the largest diameter it could be. And of course there's room where you could actually make it longer. Well, the theory behind adding one of those fancy chrome tubes is, yes, it does increase performance a little bit, only noticeable under high RPMs. Yes, when you have a exposed air cleaner like a K&N and not one of those plastic boxes, you get to hear that engine wah sound, or sort of a sucking sound too, which some people like. So the theory is true. If you have a long, smooth, shiny metal pipe, yes, there's less aerodynamic drag inside of there when the engine's running at high RPMs, so you will get slightly more airflow. And if you have a cone-shaped K&N air filter on the front, that's less restrictive than an airbox, and it allows engine sounds to emanate, and of course it increases flow too. So you won't really notice anything until your RPMs start to get maybe past 3,000, 3,500 RPMs, and then you'll notice the slightest increase in top-end performance and maybe the slightest increase in top-end fuel economy. Not a big deal, but kind of looks nice under a hood with a lot of black. Well, now to show you how it works on a Jetta. I had to use conventional warfare to win the battle to get near this car because they were living in the mirror. Those fucking bees are back. I got stung twice this week. Well, anyways, we got a typical 2-liter gasser engine in here, VW style. And this has a combination intake plenum here that gently turns into runners. And the runners continue underneath. To have good, effective tuned runners for your engine, they should have smooth curves, fairly smooth inner walls. You can polish them and make them better. And the volume from about like here to here of the hole inside in cc's should be close to the same volume as your cylinder is when your piston goes down. The idea being, in between every stroke of the piston when it's waiting for its new charge before the valve opens, already a pocket of air has collected in that tube, and it's there waiting undisturbed, ready for the next charge just to get sucked in. So that makes the engine torquier at low RPMs, and at high RPMs it has another advantage too. In the higher revs it has what's called the ram air effect. Air moving in has velocity to it. It means it's traveling, it's dynamic. So the faster you are revving your engine, or the RPMs are, the faster the air is rushing in. Well, since something that has velocity and mass, it also has kinetic energy, which means the energy of motion. That means if you have a mass of air and it's flying along and it hits something, it compresses against it and builds up against it in a little pressure wave. Well, compressed air in a pressure wave is good for an engine. That means when the valve is closed waiting for the next charge during high RPMs, a pocket of air has already moved, piled itself up against the closed intake valve, and then when the intake valve opens, the air has its own dynamics of motion and wants to push itself in, almost like it's a little bit supercharged or pressurized. That's good for performance. That's good for performance. On those old-fashioned V8 engines of years gone by, which I'm not too particularly fond of because I'm cheap, they had things called tunnel high-rises. Well, basically the higher you made your tunnel high-rise, the better that engine performed at high RPM, so long as you had a cam and exhaust system that would allow the air to flow out and match the, the tuning properties of that intake system. Some people like to add throttle body spacers or carb spacers. If you were going to put one on a fine engine like this, my 3.8 96 minivan, future diesel, you would take off the throttle body here with 2 bolts and add a spacer right here where it bolts to the intake plenum. This sort of just changes your characteristics of performance a little bit. It doesn't actually give you any horsepower, but it sort of changes the power band. Notice the good sized long runners on this engine. It's well designed. Now let's talk about forced air induction systems when we're talking about air induction in tuning cars for flow. Turbo cars and supercharged engines are a compressor. They are blowing compressed air into the intake manifold system, runners and plenum, whatever. And so when the intake valve opens, a charge of pre-compressed air that's way above atmospheric pressure rushes in unhindered. Most fuel-injected cars have what's called a map sensor. It's got a little diaphragm in there and a little chip the diaphragm presses against, and it measures air pressure. It's called manifold absolute pressure sensor. A vacuum hose goes any place at the intake manifold so that it can read the pressure in there. If your car wasn't designed to run at pressures above 0 psi, it has a normal map sensor. That means that your engine is not supercharged or turbocharged. 0 psi may sound confusing, but air pressure is actually air pressure. There's 16 pounds per square inch of air pressure at sea level pressing down on every inch of your body and every inch of everything. So when an engine is running, it's not actually sucking air in, it's just creating a vacuum and air pressure pushes itself in. Well, on a typical engine with no forced air induction system, you can never get quite to 0 psi where air exists at unhindered maximum flow. So if you were to add a supercharger or turbocharger to Garrett's next farm piece of shit he's going to destroy, then somewhere on the intake system you would have a supercharger or turbocharger adding pressurized air to the plenum. Well, without a completely different computer, map sensor, and electronics for this car, and bigger injectors, this Toyota or any other car would not work properly. The intake mixture would be way too lean. Your car couldn't understand pressures above 0 psi and know how to give it more fuel, or have the capabilities with larger injectors to do it. So your car would work terrible. So if you are planning to add a forced air induction system of any sort to your engine, you have to be aware of a map sensor that reads pressures up to, say, 15 psi, like I run my car on. You see, forced air induction map sensors have a different range of pressures that they can read. Some only go up to 10 psi, some 7 psi, some 30 psi. You never know. Then you have to have the appropriate computer that can read those different readings it's sending it. And higher rate of flow fuel injectors. And maybe in the gas tank even a higher volume, higher pressure fuel pump. So unless you're starting with a whole complete kit that was engineered for the engine you are using it on, you're almost out of luck if you want to increase the performance on your car by adding air induction that's forced. Because likely your grocery getter won't work right, will burn the valves, have white spark plugs, pre-ignition, and lots of problems, and maybe even less horsepower. Now, lots of people have thought of putting a ram air tube on the front of their car, and maybe even a hood scoop or something like that. This is a little more innocuous because it's hidden under the line of the hood. Well, if you have a carbureted car, that can work out not bad, but you may have to rejet it for the speeds that you might be driving at when you're using that. But if you have a fuel-injected car and it has a good intake system where you're allowing lots of air to ram in, well, then it's also going to confuse the computer and map sensor and cause your car maybe not to run too good. There's a limit to how much air you can force in there that your computer can read before it causes your car to run poorly. So you might want to forget about adding a pressurized air system to your vehicle without doing serious modifications and having an understanding of electronics. Unless you're a guy like me and you can pretty much pull off anything. One final thing, if you do manage to get a kit and you get it all working right, and you have a typical engine with a steel without a steel crankshaft, with a cast iron crankshaft, with a low volume, lower pressure oil pump, you know, with weaker pistons like they come with stock that are made of cast aluminum, well, your engine probably won't last long. You'll damage the crankshaft, spin bearings, crack pistons, maybe even bend rods. It's almost a waste of time to build up an engine that isn't designed from the bottom end up.